Hi, this is Shomik Vishwas. Welcome to my class of Norton Theorem. That is the class 2 of that Norton Theorem. Today our objective is using Norton Theorem on that AC analysis. Here I have taken one AC circuit. It means R, L, C, all these components are present. So find the Norton's equivalent circuit of the terminal 1, 2. Okay. So here, as you can see that one 2 ohm resistance and one inductance of 5 Henry J5, they are connected in short. I1 is flowing as a whole, taking branches of this particular branch where J5 and 2 are series to each other, in this other branch where that 4 ohm is connected to a tap. The tap is there named as 1, so it is 1 and 2 node. You have to find out that voltage, Thevenin voltage, it is a Norton circuit, so you have to find out that short circuit current and R Thevenin. So how to do this? First of all, the I is given as 5 of that angle 0 ampere. So just see this, if you are connecting that ISC, short circuit current, so the current will take this path and that final this path. So the capacitor will not linked by the current. So finally the current which is flowing to this path, if you are applying current divider rule, so it is basically the resistance of this one and this one. If it is R1, if it is R2, and the total current must be flowing to this is obviously the opposite arm resistance. So if it is, say, if it is R2, if I write it as R2, here if I am writing as R1, so what is the current of this branch? That is R2 by R1 plus R2. And for this branch it's just the reverse, means that R1 by R1 plus R2. So if you are taking this one is I1 and this one is I2, so obviously I2 means this one and this must be I1. So the same thing I have applied here, and I will be getting that value is 5 with that angle 0 degree, 2 plus J5, here it is 2 plus J5 plus 4, so all total 6 plus J5. If you are taking that 6 plus J5 in the amplitude modulus value, so it is 7.81, angle of 39.81 degree. So just divide it, you will be getting 3.45, and subtracting this two value, in that value and that value, should subtract this value from that upper value, so it is coming as 28.39. okay, so total is, this is the ampere. Now this is the short circuit current, ISC. Fine. Now the term you have to find out ZTH, otherwise you cannot make that entire circuit. ZTH, if you are finding out the ZTH, so what you have to do, you have to see from this end. So that is, if you are watching this particular point, so that is 4 plus 2 J5 and that J2. These branches are, means this total and this one are parallel to each other, so that is J2, 4 plus 2 plus J5 means 4 plus 2 plus J5. okay, so that is the ZTH. So that is doing some sort of mathematical calculation on that. It is 10 minus J12, you can do it by yourself, I did it. So that is 6 plus J3. Now the amplitude modulus conversion, and finally this one and this one should be divided, it is coming as that ohm. So it is a circuit where that value is ZTH given, the current source is given, it is not an equivalent circuit where that RL, here Good question. What is RL? RL not given, so I should write it RL of 1 and 2. That's the problem. Can be completed. Now, I don't know how it seems to you, but there is a AC analysis. So the second question I have, the question number 2. Here, one hybrid model of transistor is presented in front of you, where that is R1. Actually it seems as eta, not it is eta, it is R1. That is mu of V0 plus minus, it is a AC voltage source, it is a input voltage Vi, that is final voltage V0. One parallel resistance, that is R2, and that is alpha I1, it is a current source on this. Okay, so here that particular current source is given, so you have to find out that Norton equivalent voltage. So how to do this? Finally, if the current is I right here, so here you can see this. So what is mu V0? Voltage source, that is I. So Vi minus mu V0 by R1, that is I. Okay, so that particular voltage, what is getting on this particular one, that particular current, we can write it as Vi minus 0 OC into mu. Now here, that is alpha I1, that is R2, they are in parallel combination. So what is I, that is following this particular branch? Here I means Vi minus mu V0 by R1, so that is I. So the same thing will be flowed to this. So if it is V0, VOC, so they are shorted to each other, so obviously the node point voltage is VOC, so they are shorted obviously. So finally that particular VOC and that mu V0, if you are comparing this, so obviously that V0, this particular V0, we can write it as VOC. Okay, so finally if you are taking from this side, so what is V0 actually? V0 or VOC or open circuit voltage, whatever you can write. So that is basically the drop of that current source and that resistance. So what is the drop here? That is V of OC equals to alpha I R2. Okay, now what is I? That is previously calculated here, that is Vi minus mu V0. We are just putting this value, and finally we are solving it. What is for VOC? So VOC is coming as finally alpha R2 Vi by R1. So that should be divided by 1 minus this alpha mu R2. So by division process you will be getting as, that is VOC. Now what is IN? Short circuit current. It means this is following the short circuit path, so it should be alpha I. Alpha I means that is this current, it means that is Vi by R1. So finally ZTH equals to that VOC by IN. Just putting in this value, finally we'll be getting that is R2 R1, that is R2 into R1 divided by 1 minus mu alpha R2. Okay, so these two are the examples of the Norton's application in that AC analysis section. So therefore that AC analysis, you may have a lot of different problems also. You can have different good authors book, you can have different shorter problems. So please do this, solve it by yourself, as I have shown you that way of that analysis in DC analysis in AC Norton's theorem. So please do a lot of practice on that. If you are getting any sort of trouble or any sort of problem, you should write me freely on my given email ID. Thank you.